Data that has a time component requires specific visualization techniques. So if you recall from our early visualization history, one of the very first data visualizations that we have record of is actually a time series visualization. So the x-axis on this plot is time, and we're seeing the movement of the planets over time. And this has stayed constant as one of the most common ways to visualize data with a time component. So this is a famous time series plot. It's getting a little bit old now, but this is the peak breakup times according to Facebook status updates. And you can see that there is some cyclical pattern. So Mondays, there's a spike in breakups, and then there's some periodicity to the year as well. I also really like the annotations on this plot. So spring break, spring clean, April Fool's Day, some kind of terrible joke, Christmas Day, too cruel, and 2 weeks before Christmas holidays, clear your conscience. So that's a time series graph. So we're just plotting time on the x-axis and then the number of breakup times on the y. Here's another time series plot. This one is about voter registrations, and we can see the number of in-person and remote registrations, and we've also got some small multiples going on here. This is a recent cover of Time magazine. It's a time series visualization, but it's been made into a piece of art. And I'm going to see if I can show you the animation of how Jill Pelto made this cover. I just think that this is a nice process document where you can see she is plotting these different time series and then filling them in to look like parts of that mountain range, and then getting the other information over the top. So an interesting application of time series. So this is an important consideration for many types of data visualizations, but it is particularly important for line charts, which time series visualizations are. And the question is, does the y-axis have to start at 0? We've decided that for bar charts, the y-axis does need to start at 0, but for line charts, there are arguments for cases when you would not need to start at 0. So this is, I think, the MMR vaccinations in England from the 2015 year. It looks like it's going back like 10 years, but it was released in that year. And if we look at that plot, it basically looks like it is stable. But the story that you might be telling as the data visualizer is something about a dip. And so maybe it makes more sense not to start the axes at 0. You see they've put a little icon to show that there's a break in the axis, and that might emphasize the trend that you're trying to show more accurately. Another common example here is if you were going to show average annual global temperature in Fahrenheit, the average temperature never gets anywhere near 0, and so it just looks like a completely flat line, and maybe you actually want to show something in, sort of the range of the data. So I don't think that you always need the y-axis to start at 0. A very famous example of a time series visualization is this plot about gun deaths in Florida, and there was a ton of debate about this. I'd love to hear what you think about it, because this one, the y-axis starts at 0, but 0 is the top, and then larger numbers go down. So this was trying to look, I think, like blood dripping down the page, but it might have made the trend look like it was happening in the opposite direction. Other than time series, one way to visualize data with a time component is a calendar visualization. This is from an early paper about that visualization type, but you might have seen a calendar visualization, for example, on GitHub. These are Hadley Wickham's GitHub commits, and you can see when he takes off time for the holidays. He's really good at taking off the weekends, and you can see when he's more or less productive because each of those squares is colored in based on how many GitHub commits he made that particular day. Of course, we've seen animation as a way to encode time. So the frames of the animation are showing the years in the Walmart visualization. There is a visualization type called stream graphs, which is kind of like a density plot or something, or like a stacked density plot. And it's showing something over time. This is from the New York Times. I think Amanda Cox was the main author on this piece. And it's showing the box office receipts of movies such as Spider-Man 3 and Transformers and things like that. This is kind of an old example. This is by Fernanda Villegas and Martin Wattenberg, among others, and it was called History Flow. This is a tool that they developed for IBM, and this example, which I know is blurry, is showing how the history of Wikipedia articles unfolded. So all the examples that we've seen so far have been visualizing a time variable and then one other variable. But what if you have more than two variables that you want to show over time? One option that you would have is to make a dual axis plot. So have one axis on the left and one on the right, and then maybe that would allow you to show something about the relationship between global GDP and German GDP. But this is seen as bad practice, and the reason is because typically those two scales aren't the same. So in this example, the scale on the left is going from $40 trillion to $80 trillion, and on the one on the right is going from $2.5 trillion to $4 trillion. And the way that those axes have been aligned makes it look like there's a strong relationship between these two things, but the choice of how you align the axes can make the picture look really different. So here's just an illustration. If you made the scale of one start at 0 and the other one not, you might be able to see the orange looks steady, but the blue looks massively increasing. You could start the axis for the blue at 0 and not the orange, and then blue is going to look like it's going increasing, but orange is kind of steady. You could make them both look steady. So you can basically manipulate this graph to make it look like any type of relationship. So this is why data visualization critics say that it's bad practice to use a dual axis plot, and it's why tools like ggplot2 make it really hard to create a graphic like that. So if we're trying to think of a better option, let's recall this graphic by Menard on Napoleon's March on Russia. So this has a ton of information encoded on one plot, but it's not using a dual axis chart. And this one's kind of complicated to read, but I think that the idea from this plot shows through into more modern examples of connected scatter plots. So a connected scatter plot will allow you to show two variables, in this case the price of a gallon of gasoline and the miles driven per capita each year. And you plot those as two axes on your plot, an x and y. And so that actually allows you to show the relationship between those two variables. And it would be one thing to just do a scatter plot with those dots, but if you want to show the time relationship there, the way to visualize that is by connecting the dots, and this connected scatter plot lets you see how things change over time. So in this plot, the annotation says the swing backward, and the average number of miles that Americans drive annually begins to fall, so the chart appears to turn around. So this is an additional level of information beyond the scatter plot by connecting the dots. The other way that people often show information that has a time component is in a timeline. This is maybe more of a narrative strategy for someone who is a data journalist, but it's also kind of like a visualization. So one thing to consider is there are two separate ideas here. A timeline shows actual spans of time, and it's proportional. So the space between 2 points, if they are equally spaced, they should be equally far apart in time, and then larger spaces should correspond to larger time periods. But a chronology might show different amounts of time as equally spaced apart, and it could be just presented as a list or a slideshow. So there are some questions that we can ask before sketching a timeline idea. You'd want to think about if the story was about hours, days, years, or decades. You'd want to think about that chronology versus timeline idea. Are they going to be represented with equal space? Do you need parallel time periods? Are you going to combine it with other kinds of visualizations like a map or a line graph? Do you need to add some photos? And how much text is necessary for the story? And if you want to build a timeline, there is a tool called Timelinejs, which is an open source tool from the Knight Lab that is to allow data journalists to easily create timelines. So you could scroll through and look at the examples, but it's been used by outlets like Time and CNN and some of these international venues like Le Monde and more local news sites like the Denver Post. This is a timeline that I really like by Christine Zhang and Andrea Robertson, and this was released right after the 2016 election. I think they were hoping that Hillary Clinton would win and they could show Hillary Clinton on this timeline and the United States electing a woman leader, but the election didn't go that way, and they'd been preparing this story, so they decided to release it anyway. And this is an actual timeline because the space between the points is proportional. So you can see the space between 1960 and 1979. It's a pretty large distance, but then after 1979, it looks like it's becoming more regular that countries are electing women leaders. If you're going to make a timeline, you might want to think about if the timeline should always be a line. So sometimes it makes sense to have a line, but other times a circle or a spiral might be a better way to visualize that data. And so there's some recommendations, like you should use a vertical timeline if you need a fast lookup, and avoid a spiral timeline if that's important. So this kind of reminds me of the perceptual stuff. Like if you want someone to be able to perceive it really fast, here's what you should do. But if you are going to, do something that's more creative or expressive, that might be more appropriate for your data. But you might want to include a tutorial or more visual clues to assist the user in understanding. So this is a timeline in a circle that I really like. This is by Zan Armstrong, and it's about when babies are born. And so this is using a circle as the clock. So we can look at within a day, what time of day are there more or fewer babies than average being born. And we can see things about the variability of birth times, as well as where, C-sections get scheduled. They're showing, kind of how to read it with these annotations that are kind of calling out important points. And then they also have the week as a circle. And again, it makes sense to have a circle because then you can see how the data connects. So I think they are showing the end of Sunday into the beginning of Monday. And again, how you can see the pattern, which has something about scheduled C-sections as well. So fewer of those are scheduled on weekends. And so there's this dip on weekends and in the middle of the nights. And then they also show the whole year as a circle for a timeline. And again, you can see how there are times with more or fewer babies, and some of that has to do with C-sections as well, although not all of it. So those were some ideas of how to visualize time and timelines. There's lots more ideas. This is the TimeVis Browser, which is a survey of visualization techniques for time-oriented data. It's got things like, do you want it to be abstract or spatial? Do you want it to be univariate, just one variable, or multivariate? More than one variable? Do you want it to be linear or cyclic? Do you want it to be static or dynamic? Do you want it to be 2D or 3D? So you could go explore this to see some other creative ways that people have thought to visualize time data.